I'm a project manager based in Western Australia on this project. So DWG facilitate and coordinate funding grants, and this particular grant is called a Game Changer grant. It was an application to the federal government under the Saving Native Species program. It's a fantastic one to be on, and we've assembled a team here in WA consisting of people from the scientific industry, civil industry, as well as research and communications. So we will be pretty busy for the remainder of this year into early next year. DWG's got a long history of mitigating Phytophthora dieback, particularly raising awareness. So now we want to extend that knowledge and over 50 years of research in Western Australia to inform other parts and other states of Australia how significant this issue is and actually what they can do about it. This project has the potential to make a massive positive impact for the environment across Australia and many states where Phytophthora is actually an issue.
My role in the project essentially is superintendent's rep for the contractual execution of the project under Bruno Rickley, but I also bring to the project my technical knowledge and expertise to guide both the major contractors of Arbor Carbon and Colford when it comes to dealing with the materials. Essentially, the scope of this project is for civil construction because they are the main culprit for spreading the dieback pathogen in their construction and maintenance activities.
To be able to source gravel from sites that were previously infested and treat with methyl sodium to eradicate the pathogen is great, because prior to that we were sourcing gravels from jarrah forest that was disease-free or non-infested by the pathogen, which is basically silly in many ways because we are clearing healthy, dynamic forest to obtain gravel to stop the spread of the pathogens.
Colford is a 616 hectare property located 90 kilometres in the southeast of Perth down Albany Highway. The property is a dedicated site for agricultural and industrial purposes. Colford's responsibility in this project is for the gravel processing and the fumigation process. For this project, we will apply our quality management system. This includes site inductions, toolbox meetings, safe operating procedures, safe work procedures, access control, PPE and chemical storage.
I am leading the team at Arbor Carbon as Arbor Carbon's project manager. I've played a big role in experimental design as well as leading the fieldwork down on the ground as well. So the preparation of the inoculum is being undertaken by Vegetation Health Services at DBCA. Once these have colonised the petri dish, they are transferred into flasks containing small sections of young pine branches that have been cut into segments, and the cultures colonise the plugs. The plugs are taken from the flasks and they are inserted into burley cages, where they are then inserted into slotted PVC pipes of various lengths, which are then inserted into the gravel pile at different depths and at different heights. So once these sample tubes are inserted into the stockpile, the methyl sodium that has been applied to the gravel converts to methyl isothiocyanate, or MITC gas, which is actually the fumigating agent. After 28 days, we come back to the pile, we retrieve the samples and we take them to the lab. In the lab, they take the samples, they split them in half and they place them onto Phytophthora selective medium. If the Phytophthora grows, then that indicates that the fumigation didn't work, whereas if Phytophthora doesn't grow, that indicates that it has been destroyed by the MITC gas and therefore the experiment has worked. So at the same time, Murdoch University will be monitoring the MITC levels in the air around the stockpile at different distances, at different directions from around the stockpile in order to monitor the environmental levels of MITC throughout the withholding period. So simultaneously, Murdoch University is placing sample tubes alongside our sample tubes to collect intergranular MITC levels throughout the 28-day withholding period. They will take samples regularly to monitor how much MITC is present within the stockpile, which we will then correlate with our survival rates.
I'm the Plant Diseases Program Leader at the Department of Biodiversity, Conservation and Attractions, or DBCA. And DBCA and WA as a whole run pretty much a world-leading program in managing and mitigating the impacts of Phytophthora dieback. So DBCA's role in this project is primarily technical support through the Vegetation Health Service Laboratory. So that's helping to produce the inoculum that goes into the studies about how effective the metham sodium is, and then also doing the diagnostics of that inoculum down the line. We also have our dieback interpreters who've committed to longer term where the products get used, going out and actually observing the vegetation along those roadsides or other areas where it's used. And then we also have a really important place to play with strategy, communications, and how we can make sure the project has the best bang for buck longer term. And then the very long-term goal for us, once we get all of the results in and we know how this is working, is that will feed directly into DBCA guidelines about how we're using metham sodium treated basic raw materials on DBCA managed lands and on conservation lands.
So the research trial or trials that are being run at Murdoch are all around what the treatment of metham sodium would do in materials that are commonly used in plant restoration on mine sites and other properties around where they need some sort of restoration and where Phytophthora might be present. Because if we could treat these substrates and then grow trees or plants in them afterwards, we could perhaps be able to convert some places that have been impacted by dieback to dieback-free. And so we are testing a whole range of different plant species to see how they grow in these treated materials.
Nothing possibly will probably 100% eradicate it, but we need to have a number of different tools in our work portfolio that we can use, engineering as well as treatment, to control the risk of spreading the disease, and we can do that. Hence this project, once hopefully we approve that we can effectively treat gravel with metham sodium, will give government another option other than going in and clearing disease-free native vegetation, because that has to stop. That's not sustainable, not this year, not in 2025. That's the catalyst behind all this.
This is a game changer grant, really, because we're no longer just treating the symptoms of the disease and the environment. This is a great project. We've got so many different disciplines working on it. It's really an example of demonstrating a shared responsibility for biosecurity management. And we're doing this with First Nations people, we're doing it with some of the best scientists in the country, we're doing it with fantastic people sponsoring this, plus we have government agencies as well. And I hope the results that we achieve out of this project will be helpful to many parts of Australia and the future environment that we all live in.